Hey everybody, so I had you guys go to these two links. This one's for the ionic bond and this one's for the covalent bond. And in class today, what we really did is we went over the study guides. There's still a couple people out there who have not turned in their study guides, so I'm going to kind of make another video and I'm going to email that video out to the people who finished it. And then I'll put the video on Planbook tomorrow since the homework's due tonight at midnight. So if you guys can go ahead and get that turned in. And then you can view the video to get the answers and stuff like that. But anyways, that's why I'm doing this. So just kind of a review on some of these guys. So if you guys read my plan book page, these guys use the energy level models, right? So we see oxygen here. We have oxygen, have 8 electrons total, but 1, 2, 3, 4, 5, 6 valence electrons. And this oxygen has 6 valence electrons. And when we bring these guys together, they end up sharing 2 electrons from each, right? So we have 1, 2, 3, 4 of these guys, but then 1, 2, 3, 4 right here that are being shared here in the middle. If we count all these up, remember covalent bonds, we share electrons. So this oxygen is sharing all of these electrons, and this oxygen is sharing all of these electrons, right? So as I pull away and bring these guys together, these 4 are being shared. So if I go 1, 2, 3, 4, 5, 6, 7, 8, right? Now this oxygen has that full valence shell. This is why these guys bond together, is because oxygen wants full valence shell. This oxygen wants the same thing, right? He has 1, 2, 3, 4, 5, 6, 7, 8 of his. So he's good to go, right? Fluorine will do the same thing, except fluorine has 7 valence electrons. So it says 9. So 9 protons, 9 electrons, but 7 valence electrons. Remember, valence electrons are the ones that we care about. So we've been doing Lewis dot diagrams because Lewis dot diagrams show us only the valence electrons, but I just thought that this was, a little better, or just something different, to show electrons and such. So we don't pay attention to these two guys, these 2 electrons here in this inner energy level. But I know if I look at this valence shell and I see 7 electrons here and I see 7 electrons here, right? This guy needs 1 more electron, valence electron, to have a full shell, and so does this guy. And as we bring them together, we notice that we have 2 here, right? So one of these electrons is from one fluorine and the other one's from the other fluorine, but they're sharing each other's electrons. So now when I count 1, 2, 3, 4, 5, 6, 7, 8, this fluorine is now happy. He's got a full valence shell. 1, 2, 3, 4, 5, 6, 7, and 8. And he's happy, right? And we can kind of do this. Here's we did this one on one of our practices and such. So you can this is just something kind of to mess around with, because this is showing that this energy level, or this nitrogen in this case, is sharing these electrons from this hydrogen, this electron from this hydrogen, and this electron from that hydrogen, right? And hydrogen right here, we know it's hydrogen because it says, right, so nitrogen is the one in the middle here, has 7 electrons, 7 protons. And we know that these are the hydrogens because they only have 1 electron. But these guys on the first energy level, remember, can only hold a max of 2 valence electrons. So that's why these guys only have 1, 2. They are happy. Hydrogen's happy because he can only hold 2 valence electrons. Where anybody that has more than 1 valence electron, like nitrogen here, he would like 8 on his shell. He's got 5, and so he needs 3 more. Well, this hydrogen's got 1. This hydrogen's got the second one, and this hydrogen's got the third one that they're all going to share so that they can achieve their full valence shell. So there's something to kind of mess around with. Here's some stuff down here below that shows a single bond. So right here, if hydrogens only has 1 electron to share, he's going to share a single bond. So these 2 electrons right here is what it's showing right here. So this is a single bond, right? This is a single bond. And here's a single bond. So there's 3 different single bonds, because when I'm talking about a single bond, it's between 2 atoms, right? It's not between all 3 of these guys. It's just between this hydrogen. This hydrogen is a single bond between this hydrogen, and this nitrogen is a single bond between this hydrogen, and this nitrogen again is a single bond. We got some double bonds. So if we look at oxygen, O2 here, okay, that we were messing with earlier, right? He's got 6, so he'd like 2 more valence electrons. He's got 6, so he'd like 2 more valence electrons. And again, now we have 4 electrons being shared between the 2 of them, so they can achieve a valence shell. So we have actually a double bond going on here. That would look like this, right? And then there's nitrogen, which we're not going to do any triple bonds. We come over here, sodium. So again, what's the big difference between ionic bonds and covalent bonds is when I take sodium here and I bring it close enough to chlorine, this chlorine needs one more valence electron, right? Chlorine has 7 valence electrons out here. He'd like one more to achieve 8. And so as I get closer and closer, these protons here in this valence shell are really pulling this electron right here off of sodium. And sodium really doesn't care for that electron either. And so we'll get closer and closer until finally that attraction pulls off sodium's valence electron and pulls it onto chlorine. And that makes chlorine now that negatively charged ion. Sodium becomes positively charged. Sodium now has his full valence shell because he dropped off, right? He dropped off this outer shell and bumped down one, so he has a full valence shell. And chlorine now has his full 8. And so now remember, it's this give and take, right? Ionic charge, there's ion in the word. Ion is a charged particle. And so that's how we get that. So it's the opposite charges that form this ionic bond, that opposite charge that really holds these guys together. Lithium chloride, all right, chlorine we just said has 7 valence electrons, and remember the valence electrons are the only ones involved in the chemical bonds. And so it's going to look very similar to that one. What I said, what did we do? Sodium chloride there. Lithium chloride is going to look very similar. Why? Well, lithium chloride has 1 valence electron. Sodium chloride has 1 valence electron. Sodium fluoride has 1 valence electron, right? And he has 7 valence electrons. This guy, sodium chloride, has 7 valence electrons. Lithium chloride has 7 valence electrons. So it's going to look, they do the same thing. Now, if we get into magnesium and calcium, magnesium is in group 2. Magnesium has 1, 2 valence electrons, right? So he needs to give away these 2. Well, if he has chlorine here, chlorine can only accept 1. He can't accept both of these electrons. So 1 will be transferred to this chlorine, but this magnesium still has this one this 1 valence electron to give away. And so now he'll give it away. So now we have -1, -2, -1 for chlorine. And then we have +2. Why is it +2? Well, magnesium gave up 2 electrons. All right. We have calcium here. It does kind of the same deal. Has 2 valence electrons. If I move this guy over here, right? He gave his electron here to chlorine, and here's this other electron out here that as I move closer, chlorine will take that away. And now it's these opposite charges that keep these guys in an ionic bond. So anyways, then I have this short little, so anyways, if I have an ionic bond, let's go with the covalent bond, right? We're looking at oxygen earlier on here. So we got O2. So we don't draw them like this anymore. So this is showing all of the total number of electrons. We just do them in the Lewis dot structures that show just the valence electrons. So like I said, this is just practice, just kind of get a visual. So if we look at oxygen, what it actually looks like, so we're going to start off by putting 1 electron on each side. 1, 2, 3, 4, 5. Oh my goodness. Let me back up a little bit. I'm sorry. Those are way too big. So about 1. There we go. 2, 3, 4, 5, 6. So we have 6 there. We have 1, 2, 3, 4, 5, 6 electrons. And so we now know that these guys want to share with each other, right? These 2 are unpaired. They're alone. He's alone. He's alone. So let's pair these guys up, and they'll share each other, right? They'll pair up and form a chemical bond. These guys will pair up. And so when we end up redrawing these, we'll draw oxygen that has a double bond because we have 1, 2, 3, 4 electrons being shared between the 2 guys, right? And then I'm still going to show these electrons out here. 1, 2, 3, 4, right? 1, 2, 3, 4. And so each line essentially represents 2 electrons, right? Here in this line, there's an electron here, 2 electrons. So now that's represented by this straight line. So there's 2, there's 4, 5, 6, 7, 8. Oxygen has 8 valence electrons. He's happy. 1, 2, 3, 4, 6, 8. Right? There's 2 electrons in each of these lines. So that's a covalent bond. There's a big difference. So you should draw your covalent bonds like this because they're sharing electrons. I'm not showing that. So when we do our Lewis dot structures for ions and such, right? I know that we have 1 valence electron for sodium, and we have 7, like we just talked about earlier, with chlorine. 1, 2, 3, 4, 5, 6, 7. Chlorine can only accept 1 electron, which is okay because sodium only has 1 to give away. So sodium will give it, right? He won't share it, he'll give it away. And so when we end up making sodium chloride, when we do a Lewis dot structure, we have sodium, who, like I said, lost his electrons, so we don't draw them inside our brackets anymore. And what's his charge? He becomes positive 1. Why? Because he lost a negative, so he becomes more positively charged. Chlorine gained his electrons, and now he has a full 8, a full valence shell, right? So 1, 2. Go ahead and draw chlorine in here. 3, 4, 5, 6, 7, and 8. Some brackets. All right, and then we show that they're held together like this. So we have this is how we show covalent bonds, right? And down here with the brackets, this is how we show ionic bonds. Okay, so notice some of you guys, I'm going to do this, and this is going to be incorrect. Okay, I'm going to do it the wrong way. Some people will do sodium, right? Because this looks similar. So this first step, you need to do this first step. Here's step 1. I'm doing these Lewis dot structures, right? I'm drawing and I'm connecting what's going to happen. I'm drawing and I'm going to see this electrons being given up. So they look very similar to start off with. But I don't want to do this sodium bond and then chlorine. Okay, that's wrong. That's wrong. This bond is indicated by their opposite charges and their brackets here. Okay, so there's my short little video for those of you who have not finished your homework yet, but this is kind of review. Don't forget, if you guys go on to my Teams page, all right, if we go to Teams, I go to, let's say, second hour Teams, right? There's still my periodic table Quizlet. It's actually on Planbook as well. So you guys can go ahead and mess with that. Please get that periodic table done. I'll try to get it back to you. But I just took it for participation today. It seemed like a lot of people had trouble with it, or not trouble with it. We didn't get it finished. So there was a lot of people who just didn't get it finished. So I took it for a participation grade. So please watch my next video once you turned in your homework. Like I said, you'll have to let me know so I can send you that link. But anyhow.